Hello, everyone, and welcome to Nuclear Energy Information Services Night with the Experts. And tonight we have a great expert, and we're really honored to have him. It's Dr. Edwin Lyman of the Union of Concerned Scientists. He's often comes in and listens to the other experts, so we're really happy to have him tonight as our expert. So with nuclear energy, so I'm Gail Snyder. I am the board president of Nuclear Energy Information Service. And what we do with Night with the Experts is we do what we call flip the script. So usually when you come on to these kinds of things, you hear an expert talk for an hour, and then, you know, maybe couple people get a chance to ask a question. And a long time ago, we thought, you know, people really want to ask the experts questions. So we give our expert 20 minutes or so, sometimes longer, but then we give the majority of the time to you, the guests, to ask questions. And the way we do that is through our chat. And one of our board members will moderate that, and she'll explain, if you haven't been on before, she'll explain how that happens. So tonight, I just would like to first introduce our board members and our director before I introduce our expert. So first, I'd like to introduce our director, David Kraft. Dave, would you like to unmute and say hello?
Yes, this is Dave in Logan Square, Chicago. Thank you for joining us tonight.
Great. And our other board member, we have one who I think Linda's not on yet, but she'll be on, joining us a little later. And our next board member is Jan Bodart.
Hi, I'm Jan Bodart, and I am very happy to be here and thrilled that Ed Lyman is going to be our expert. And thank you all for coming. I always say that, I'm pretty sure you're in for a very informative and interesting evening.
Thanks, Jan. Jan does the lion's share of the work putting together a night with the experts, finding an expert and coordinating with them. And she does a really great job in trying to find people who fit the bill of expert and provide us with timely and interesting information. So tonight's Night with the Experts is titled Guinea Pig Nation, How the NRC's New Licensing Rules Could Turn Communities into Test Beds for Risky Experimental Nuclear Plants. Under the direction of Congress, the NRC is developing new regulations to facilitate licensing of experimental reactors by relaxing safety and security standards and by relying on safety demonstrations that utilize computer simulations rather than experimental data. The main focus of this effort, known as Part 53, is being written with an unprecedented level of industry involvement. If Part 53 is enacted, first-of-a-kind reactors could be located in densely populated urban areas without any provisions for emergency evacuation planning, without security forces to protect against terrorist attacks, and without highly trained operators, and all without meaningful opportunities for public input. And tonight, Dr. Edwin Lyman is going to speak to us on this issue. And I think what we should know is that Dr. Lyman is one of the go-to people when things are happening with the NRC. So I follow Ed Lyman on Twitter, and I would advise you to do that as well. It's his Twitter handle is Edwin Lyman, EDWIN Lyman, LYMAN, at NUC Safety UCS. And so a lot of times when things are happening in real time, I don't know that you know this, Ed, but I go on Twitter and I see what you're saying about it. I see what you're saying about it. I see what Arnie Gunderson's on here. I see what kind of the top experts that I can think of are saying to see what kind of the current updates are. And I think that's a great resource for everyone. So just to introduce you, Ed, Dr. Edwin Lyman is Director of Nuclear Power Safety at the Union of Concerned Scientists and former president of the Nuclear Control Institute. He is a member of the Institute of Nuclear Materials Management. Dr. Lyman is an expert on nuclear proliferation, nuclear terrorism, and nuclear power safety and security. He is widely published and is co-author of the book Fukushima, The Story of a Nuclear Disaster. With that, Edwin, thank you so much for joining us, and I'll let you start.
Oh, here we go. Okay. All right, well, thank you, everybody. I'm glad to see so many of my friends out there this evening, and for a rather depressing talk on my experiences trying to hold the fort here inside the Beltway with regard to a major effort on the part of the NRC and the industry to essentially rewrite the rules that govern safety and security for new nuclear power plants. And it's kind of not nearly as well publicized or understood, I think, as it really should be, the implications of what's going on. So I'm glad to see you tonight, and I'll just launch into it. So it shouldn't be a surprise to this audience that nuclear power is trying to deliver on its promises. That doesn't stop the industry from continuing to promise these things, but even supporters like the director of the International Energy Agency just said he himself admitted that the industry doesn't have a very good reputation for delivering on time and on budget. And I think that isn't a surprise to any of us. And so what are the fundamental reasons for this? Well, the industry is looking to blame outside factors. So first they blame the design, the large light water reactor, which is the workhorse of the current fleet in the US and abroad. The industry feels like they have to do something different to convince the public that they're not going to end up making the same mistakes and ending up with the same failures. So they've glommed onto this notion that if reactors are shrunk down, that is small modular reactors, or they go to exotic designs that use other types of coolants, non-light water reactors, sometimes called advanced reactors, that they can achieve all sorts of wonderful things. They'll be cheaper, you can build them faster, you can operate them more cheaply, you can put them pretty much anywhere. They're passively safe, so no matter what happens, there's no need to actually have backup safety systems because nothing bad's going to happen in the first place. They'll just shut themselves down, walk away safe, you know, those slogans. You can use them to do all sorts of neat things like providing process heat for industry, making hydrogen, mining Bitcoin, etc. And you can even recycle your own nuclear waste or use uranium more efficiently. Now, needless to say, none of these are proven, but they are, the industry is holding out these new designs as the savior of the industry and a solution to climate change. And so we have a whole menagerie. This is just a small sampling of everything that's out there, from small modular light water reactors that is very similar in a lot of ways to current technology, except with significant differences. NuScale is the prime example of that. The liquid metal cooled fast reactors, a technology that has not had success over the decades in most other countries, but there's now a big push to build fast reactors here, and Bill Gates' TerraPower is the poster child for that. Gas cooled reactors like X-energy, molten salt cooled reactor, molten salt fuel reactors, and finally the micro reactors, these very small units, less than 20 megawatts. And Oklo, again, is sort of the vanguard of this idea. But the industry also is scapegoating the regulator. So they have argued successfully to Congress and elsewhere that the NRC's licensing rules are the problem, that these are dinosaurs, they're stifling innovation, they're holding back these superior technologies. So here's Nuclear Energy Institute complaining about over-regulation, protracted reviews by the NRC, which are driving US companies out of the domestic market. What we need is a modernized licensing process, more efficient, timely, et cetera, et cetera. So bottom line is all of this is being engineered to reduce the cost of these reactors, because if you hold everything else equal, a small modular reactor or a reactor that uses coolant other than water are going to be more expensive than the current large light water fleet. If you shrink down a reactor, you're going against economies of scale. I don't know if everyone saw NuScale's the latest revelation that their predicted power cost for their first project at Idaho is estimated $120 per megawatt hour, which is well in excess of operating nuclear reactors' power cost, and certainly renewables. The economies of small, the claim that you can compensate for these diseconomies of scale with the ability to mass produce these reactors, certainly not given and may not be true for operating maintenance costs, which may not scale the same way. And if you're talking about other types of reactors that use other coolants, there are any number of reasons why those are not going to be cheaper than current plants, but not the least is there's no supply chain for many of the materials and fuels that would be required by these reactors. So this push for revising licensing is really an attempt to weaken the safety and security costs that the industry think are what's making it too expensive. And so they've been pushing for a whole range of regulatory rollbacks, from less stringent siting requirements, so you can deploy reactors at coal plants, decommissioned coal plants, or even cities, airports, etc. That you don't need a large pressure resisting containment, or you might not need a physical containment at all, that you don't need any emergency planning requirements off-site, that you don't even have to tell the neighbors across the street that you've got a nuclear reactor in your backyard, that you can operate with fewer operators than are currently required, even zero, because there's talk of autonomous operation, and those fewer operators could have less training, fewer qualifications. You could also have zero armed responders to respond to a terrorist attack. That is, no armed officers who would be there to prevent terrorists from trying to attack a plant, and other current requirements that would be rolled back. So the NRC's current licensing rules, which have been in place for many decades, going back to Part 50, essentially just going through the different licensing pathways that are available. So Part 50 is this two-step process where first a construction permit has to be obtained, and then an operating license in order to start the plant up. Part 52 is a way to try to get around that two-step process by having a combined operating license that might reference a certified design or a standard design approval. And in addition to the parts 50 and 52, there are a lot of other sections in the rules that govern the safety and security of these plants, from the requirements for siting, for security, for doing environmental impact statements, and for protecting both the employees and the public against radiation. But fundamentally, these rules are deterministic, meaning that, for instance, if you're thinking about accident safety, that you postulate what could happen. There's a range of accidents that are called design-based accidents, and these were developed over decades based on judgment. This goes up into including a core melt, but you have to assume the accident happens, and then you show that you can meet dose criteria at the site boundary and at distances away, only relying on what are called safety-related structure systems and components. That is the most reliable, or the equipment that has to meet a very high or relatively high standards for quality assurance, which is expensive. The deterministic rules also require an armed response force that currently has to interdict and neutralize a terrorist attack.
Hey,
That
I need to.
requires a 10-mile emergency. Sorry, it requires a 10-mile emergency planning zone. And for events that are what are considered beyond the design basis, that is, they weren't around when the design basis accidents were first written into the rule. For instance, what happened at Fukushima in 2011, which is essentially a long-term loss of all electrical power. That's something that was not a design basis accident. So there are requirements for some of these beyond design basis accidents, but they're generally less stringent and that those, or the requirements are less stringent than those that protect against the design basis. For instance, the flex equipment, that is portable equipment that the NRC required utilities to buy after Fukushima, does not have to meet the same quality assurance or reliability standards as the design basis equipment. And also there's a set of general design criteria. These, again, have been around for many decades, and they include reasonable things like the reactor has to have an essentially leak-tight containment. Now, these rules were developed with a focus on what was really available and deployed or being deployed, that is large light water reactors, but in principle, most of those are applicable to other types of reactors, including non-light water reactors, with some exceptions, but those could be dealt with relatively simply. And any applicant can also seek an exemption if there's a rule they don't like, if they think they can satisfy the criteria for not meeting. Now, underlie the industry's push to roll back safety and security, they put all their eggs in the basket that these designs are safer. So a small reactor has less radioactive material to get out into the environment, therefore it's going to be safer. It might have a smaller amount of decay heat that have to be removed, so you can cool it passively, it's safer. And that's the underlying basis for all of this, the notion that the reactors are fundamentally safer, so why do they have to meet the same stringent safety and security standards? And the NRC is essentially accepting this logic, and that is underlying everything that it's doing in the advanced reactor space. This presumption that new designs will have lower probabilities of severe accidents, or if an accident occurs, they'll have lower impacts to public health and safety. Now, I could, it's another talk to actually go through why this is wrong, but we'll get it off for another day. But so far, this idea is gaining traction, or has traction at the NRC. For instance, in 2018, they approved the potential for an exemption from the requirement to have that physical containment in the general design criteria, replaced with what's called a functional containment, which is essentially no containment at all if you do the analysis and claim that you don't need that containment anymore. That's already approved. So an applicant can apply for that. They'd still have to get an exemption, though, under Part 50, but the guidance is there for them to do it. Also, there was a change earlier this year that would allow reactors to be moved closer to densely populated areas. In fact, up to the city limit, if you have the border of a city with more than 25,000 people, you might be able to put a reactor 1 foot outside of that. That's the way this guidance would read. Makes no sense, but that's already changed. And then two things that haven't happened yet. One is a draft final rule that would have a pathway for allowing the elimination of any offsite emergency planning for the reactors, provided, again, you can show with a calculation that you don't think you need it. And finally, a rule which is now before the commission that would also provide a pathway for things like no armed responders to protect against terrorist attacks. Now, on top of that, the Congress in 2019 required the NRC to essentially come up with a comprehensive rule that would fold all these things in for advanced reactors. They called it technology inclusive. And but the law does give the NRC full discretion to say what's appropriate and what isn't appropriate. So the NRC could have really limited the scope of how it would comply with this law, but it chose to go in a maximalist direction. It chose to essentially throw out the entire current regulatory framework and replace it with something else. And I think that it's on the NRC that they decided to do that, because they really bit off more than they can chew. But anyway, that is now proceeding. That's what's called Part 53, and it's currently on the schedule to be law or in the regulations by 2025. Now, even though NEMA, this law, specified that it should only apply to what's called advanced reactors, and they define what they meant by that, typically something better than what we have now, the current proposal in Part 53 broadens that to any commercial reactor. So you don't actually have to show that your reactor is better than what we have now to qualify for this rule. Part 53 is not going to be ready in time for many of the vendors who are pursuing licenses. So NuScale, for example, the small modular reactor already has a design certified, just came out earlier this year, but actually for the wrong or a smaller reactor than they actually plan to build. So they're actually going to have to do a lot of more work to apply for this larger module they want to use. So that COL could be in principle under Part 53 if it comes out in time. But there are others that want to apply sooner. So, well, first we already had Oklo. This is the first so-called advanced reactor application for a micro reactor. I don't know how that happened. They actually applied back in March 2020 for this 1.5 megawatt sodium-cooled micro reactor. They submitted a combined operating license application, but the NRC rejected it a couple of years later. Now, looking forward, DOE is funding an advanced reactor demonstration program with two power reactor demonstrations. One is a TerraPower Natrium, which is going to be in Kemmerer, Wyoming. But to meet the schedule that DOE has required, which is that the reactors are supposed to be operating by 2027, which no one is actually going to meet, but they've shifted that deadline to 2028, they still need to apply right away. So they're going to apply under Part 50. And so is X Energy for its XE100 pebble bed gas cool reactor in Grant County, Washington. So those are both going to come in under the old rules, but they're going to have to get exemption requests. Now the question is the NRC really stifling innovation with its current rules? Well, if you look at what it did with NuScale, it actually glossed over a lot of questions. It ignored design flaws, and it gave NuScale a lot of exemptions without really a great deal of fuss. They essentially gave them everything they wanted. 17 exemptions from Part 50, including important general design criteria. But the NRC does have a mandate to protect public health and safety. They can't just throw every safety standard out the window. And so the current chairman of the commission, Chris Hansen, has, to his credit, made a point that you can't just say your reactor's safer and expect to get a lot of regulatory relief. You have to show it somehow. But the key is, what do you have to do to show it? What are the efforts you have to make? And Oklo is really a poster child for this. Oklo submitted its application, and the NRC accepted it because it said it was in the national interest to license this, absurd, useless microreactor. But from the beginning, the application was really deficient. So the NRC sort of did everything possible to accommodate Oklo coming up with a custom or a unique kind of review, giving them more chances to fill in the gaps. But even so, Oklo just refused to meet the NRC even halfway, and the NRC was ultimately had to reject the application because Oklo was not complying with their most simple demands, like coming up with a credible accident to evaluate in the regulatory framework. But even after it was rejected, Oklo blamed the regulator. So the CEO, Jake DeWitt, was quoted as saying that the regulator has to adjust its practices to be more relevant to new designs. That again was blaming the regulator. So that brings us to Part 53, which, as I said, is really a complete overhaul of the rules. And it would eliminate most prescriptive requirements, that is, things like thou shall do this, it would also provide mechanisms for really weakening all the safety and security standards and more that I was talked about, all based on the purported safety features of paper reactors. Now, what does the industry really want from Part 53? Just to sum up, it's pretty clear. They want as few actual regulatory requirements as possible, and those requirements that are in place should be as vague as possible. Any detail should go into guidance, which is not legally binding and subjective when it's approved, which makes it almost impossible for, let's say, the public to object to in a licensing proceeding. The applications themselves should only contain minimal information that the NRC would have to review and approve. Most of the details should be kept by the applicant and not even submitted to the NRC. Then when the NRC actually reviews what it has, its standards should be lenient. It shouldn't have to go through the same level of depth and trying to close all the loopholes and actually confirm all the calculations. They should just do as light a review as possible. And finally, if the reactor is ever built, there should be fewer inspections and weaker enforcement. So the dangers of this process are pretty clear. Now, the NRC's fundamental goal in Part 53 is to achieve the same level of safety. Now, that goal in itself seems a little absurd. Any industry, you'd think you'd want to continuously improve, but the NRC prides itself on not requiring the things actually improve. But even so, Part 53, as it's in its current form, could actually lead to less safe reactors than the current fleet. Now, Part 53, another danger is, again, this transition from deterministic to probabilistic safety analysis. Also, it would use safety standards. I'll go into this on the next slide that will allow plants to be less safe than the current fleet. It would weaken requirements for prototype testing. That is, there are certain standards the NRC does expect under the current rules for a novel reactor that there be a prototype. That prototype might have to have additional safety features because you're testing it and you don't know what it's going to do until you start it up. But Part 53 would not have any of these current prototype requirements. And it would also severely weaken security. I could go on and on. It's just a handful, a small sample of the problems with it. Now, deterministic safety, why is that an issue? Well, at least under the current framework, you have deterministic safety. That is, you postulate the accident that you're considering, you ensure that there's a certain safety margin that's well understood, and you have defense in depth. That is, you require redundant, diverse safety systems just as additional backups in case your basic analysis has uncertainties in it. And it's important these defense in depth measures are independent and you need significant safety margins. But maintaining all this can be expensive. So you go to risk informing. The normal meaning is that you use probabilistic risk assessments, that is, these complex paper analyses of safety, to essentially focus your requirements instead of deterministic analyses. Essentially, and the way the industry really hopes that it will apply is that risk informing means you reduce conservatism, meaning you essentially can get away with more because, for instance, an accident, if you determine that this particular sequence is very low probability, well, maybe you don't have to consider it anymore, so you don't need that safety system that's in place to protect against that accident. But you know, you may question the use of that for a current fleet where there have been decades of operating experience, but for these new reactors, you don't have any of that operating experience at all. So these PRAs are really just paper studies that have not been validated. And so it doesn't really make sense to risk inform a novel reactor based on paper studies because there's so much that you don't know. And probably running out of time here. Anyway, so another problem with Part 53 is they would incorporate what are called quantitative health objectives directly into the rule. And this would be the mechanism for controlling these so-called beyond design basis accidents. That is, low probability severe accidents, worse than the design basis, that you would have some standard to show that if it happens, someone, your average person on the site boundary would have a risk of either dying from acute radiation syndrome or from cancer over a lifetime that's limited to these fairly small, but not small enough numbers. And in fact, this is a very weak standard because these QHOs were originally introduced decades ago, and they represented the level of safety of the nuclear fleet in the US as it was 30 years ago. Well, the fleet actually has gotten safer over the decades, at least on paper. But so if you still use the same QHOs that were represented safety 30 years ago, that means that plants built today could be less safe than the plants that are operating now. So interestingly, UCS and the industry both object to using these QHOs, but for different reasons. Industry doesn't like it because they don't want any specific requirements at all, but we think they're not stringent enough. And finally, there's some cognitive the industry is not a monolith. And in fact, after many years of arguing that the regulations should be risk informed, that you should use probabilistic risk assessments to reduce the conservatism of deterministic requirements, after the NRC proposed that PRA should be a regulatory requirement, Part 53, because after all, that's the basis for everything that these plants, the whole range of safety and security rollbacks that would be in the rule. The industry turned around and said, well, we don't want to have to give you a PRA. Why are you making us do the PRA? It's too expensive. So what they actually want is to risk inform licensing without actually having quantification of the risk. And that, again, doesn't make a whole lot of sense, except if you want to, if you're an applicant and you want to get away with doing as little work as possible and demonstrating, doing as little work to demonstrate these safety claims as possible. So the NRC then introduced a separate alternative framework, which was deterministic, and you wouldn't have to use a PRA. And that's an alternative, which they call Framework B. And then the industry turned around and said, well, why is this deterministic in Framework B? Why do you have the same risk-informed provisions as in Framework A? And the NRC said, well, the whole point is you don't have a PRA in Framework B, so there's no basis for risk-informing, but the industry complained. So the NRC is now in the process of adapting the framework requirements where you did need a PRA and essentially putting them in the space where you don't need a PRA, even though you don't have a PRA to demonstrate the reactor is actually safe. So it's going a very dangerous direction. So what can the public do? Right now, NRC isn't accepting comments on the language. They closed a comment period back in August. They always weigh in, and there are public meetings on a frequent basis. Typically, there are very few members of the public there expressing concerns. So the NRC is really mostly hearing from the industry. And ultimately, the draft rule is currently expected out in August of next year, and then there'll be another opportunity for actually detailed comments the NRC will have to pay attention to. So I'll stop there, and I appreciate your attention, and I welcome your questions.
Thanks, Ed. Yeah, you started this out saying, this is kind of a depressing talk, and I think it is depressing, but it is it raises a lot of questions with what the NRC has done in the past with existing reactors and how they've charted this course with the new smaller reactors is really baffling. I have a million questions, which I can't ask you right now, but hopefully we'll get to some of those. Some other people will ask them. I am going to turn this over to our other board member, Jan Budar, and she is going to explain how we will go through the Q&A section. Jan, would you like to unmute?
We have a certain set of rules for people who want to ask questions or make comments. So I'm going to call on Clark and ask him to unmute himself and ask his question. Clark Bullard. Go ahead.
Hello, Ed. Will these new NRC rules preempt state or local rulemakings? For example, could Illinois do anything to prevent microreactors from being built at every retired power plant site that has a nearby substation?
Well, I don't think the rule would change the current, what the current structure is for that. And so generally, the NRC has the preemption authority. And so states have very limited opportunity to try to block a new nuclear reactor today. And I don't think Part 53 would change that. However, there is Supreme Court has been going in the direction of possibly some rulings that would challenge the preemption authority of federal agencies. So I'm not a real expert in that, but Part 53 I don't think would have any impact on that particular dynamic.
Okay, thanks.
I'm going to call on Sarah because I don't know when she put her name in the chat. But anyway, let's let Sarah unmute and ask her question. Are you there, Sarah? Can you hear me? And
yeah, my question was just a really simple one. With these upcoming NRC regulations, is there any uniformity written into them as to who is going to pay for accidents as they occur?
Well, right. I mean, that is actually covered by a different set of requirements and laws. That's if you're talking about liability, that would be covered by the Price-Anderson Act. Again, there's no direct, Part 53 wouldn't have any direct impact on that. However, there is separately, there's an attempt to change the assessment for small modular reactors. And I'm not sure what the status of that is, but the claim is they shouldn't have to pay their insurance cost, and their assessment shouldn't have to be that high because, of course, they're going to be safer and the damages would be lower. I'd have to actually check on the status of that, but that's not currently part of Part 53, is my understanding. So, liability is still limited under Price-Anderson. I know that it's coming up for reauthorization in Congress. Someone might help me on, probably other people in the audience know better than I do when that's coming up. But Congress has not hesitated to reauthorize Price-Anderson, essentially shielding nuclear reactor operators from excessive liability.
Thank you.
Thank you. Now, our staff consists of B. Hannon, Connie Klein, Linda Ryder, and then there's a question in the chat from Francis Lawrence, and he will be after Linda. Then we have Ann Berger, Kale, and Arnie, but right now, B. Hannon, ready to ask your question, please.
Hello, Ed. This is Bruce Hannon. I am so put out with all this that I think that we should start considering the lawsuits against the people who are hosting these reactors. And what I want to know is there any kind of law firm that you know of that we could approach along these lines? Myron Cherry used to do it back in the 70s, but is there anybody like that in the business now?
Well, once, there's not much legal recourse until an application's actually filed, right? And then you can intervene. And I certainly know, at least one lawyer who's one of the national experts in how to intervene in NRC licensing cases. We can handle that offline, but certainly it's a rare, there's not much expertise, especially since there hasn't been that much licensing activity over the last several decades, but that could change. And actually you raise a good point. Maybe we need to have more lawyers who are skilled in NRC arcana, if we are going to face a wave of small modular reactor and microreactor licensing cases. What I didn't have a chance, one other danger, of course, with the way things are going is that the NRC would, the industry would love, and the NRC is going to help circumscribe the ability of the public to intervene in these licensing proceedings. Again, all fundamentally based on the idea that these reactors are so small and safe that who could have an objection to them, right? So, so that's another thing that has to be carefully watched. You have to make sure that the rules for the public to intervene and the standards that will allow them to have contentions admitted have to be strengthened even from where they are today.
I wasn't thinking of undertaking the NRC. I was thinking of undertaking either the producer of the machine or the host.
I see. So what would be well, we can talk about that later. I don't know, not sure what the nature of those lawsuits would be. So that would really, I guess the person you're looking at would depend on that.
Thank you.
So our next questioner is Connie Klein, then we'll have Linda Ryder after her. Go ahead, Connie, unmute.
Hi, everyone. Ed, I really want to thank you for doing this. It's so necessary and long overdue. I do have one procedural question. Will the slides be available? Will Ed's slides be available?
Ed, if you have them in a, if you have them in a PowerPoint or a PDF that you could send out, then we'll send them out to the people who are here.
I'll do that.
Okay.
Thank you. Hardly know where to start.
Tell me about it.
I've attended a couple of meetings for Holtec's SMR 160. There was one this week. The NRC is not requiring a separate design certification. It's going to be in a process And they haven't done anything. I mean, they haven't applied. These are pre-application meetings.
Right.
They're already asking for exemptions, however. Yeah. But there's no separate design certification. It's going to be woven in. They're going to apply when they do under Part 50, which
Right.
surprised me. But the NRC is going to allow. They've characterized it as being woven in with the construction application or on a parallel track with the construction application. So it's another issue that they're, if the design won't have to be certified prior and separately.
Well, Connie, I
And-
guess I don't understand, because under Part 50, you don't have to have a certified design. That's only for Part 52.
Right.
So, right.
That's the way that the NRC is going to proceed with this application when they apply. And at the beginning of this month, from November 1st to November 4th, there were NRC staff meetings. I don't know if you attended any of them. A couple of us attended briefly, that were to finalize, basically to finalize the letter, the final and fifth letter that's going to go to Chairman Hansen. Do you have any idea when that letter will be publicly available?
I'm sorry, which letter is this?
This is the fifth and final letter. That's how it was characterized. It's going to Chris Hansen. And in these meetings were, it was like watching grass grow. They literally were going through the hundreds of pages of this letter, word by word, sentence by sentence.
So I'm not sure which letter. Who's sending the letter? It's not clear to me.
The staff is sending this to Chris Hansen.
So it's going to be a SECI pay. Is this about Holtec or about something else?
No, this
sorry,
is
what?
this is Part 53.
Oh.
They had it was.
Oh, you mean, oh, right.
Meetings, hours, and I mean.
Oh, right. Yeah. So if you're
17
talking about
hours.
when they're going to submit the draft rule language, is that what you mean? Yeah. Yeah. So that.
I don't know. This is.
Right. So right now,
This is a
yeah.
letter, not the draft itself.
Okay. I guess I'm not. We'll have to talk about it offline, because I'm not totally clear what you're referring to. But
Kayla
I know.
Walker has her hand
Yeah,
up.
yeah.
She attended part of one of the meetings also. All right, my last question is this crap about recycling and burning fuel. Would you say that that is synonymous with reprocessing?
Yes.
Okay, because here in Ohio, the people that want these molten salt reactors characterize them both as fast breeders and recyclers, but not reprocessors.
Right.
So,
Yeah. I mean, anytime you hear recycling, you're doing reprocessing at some level. So I try to make that point every time I can, but so much of this is about controlling the rhetoric and the messaging about how you're going to safely recycle spent fuel is just it's just very hard to provide fact-based. Well, you can provide the facts, but they don't put out the fire. It just keeps going on. Now we even have the Secretary of Energy who's enthusiastically embracing recycling and saying the same, stupid things that were disproven decades ago. It's a very dispiriting business. But yes, you can't recycle spent fuel without reprocessing it. The type of processing may differ, but you're still going to reprocess and make a whole lot of waste, extra waste.
Would you say the goal is
Oh,
because,
Connie, we need to stop.
all right,
Do you mind waiting until we're through the stack or contacting Ed offline? I wanted to mention that Dave put in the chat. Now I've lost it again. Oh goodness, hold on, I'm sorry. Oh, the Price-Anderson Act expiration. It was last renewed in 2005 for 20 years.
Right. That's what I
And
thought.
then someone said, well, how much do they pay, or how much does the industry have to pay per accident? And you know that the taxpayer, by the Price-Anderson Act, the taxpayer picks up a lot of the tab for any accident. So how much does the industry have to pay if there's an accident, and
Right.
after which the Price-Anderson picks it up?
Yeah, I'm not sure what the current figure is, but it's somewhere north of $11 billion, I think.
Oh,
And
okay.
probably someone else. And right. And the issue is that the cost of an accident, one of the severe accidents probably going to be, 10 times that, 100 times that. If you look at Fukushima, right,
Oh.
the cost is already estimated to be hundreds of billions of US dollars. So this post-accident assessment that the utilities would have to pay is going to be laughably short of what the actual damages will be. So the presumption is the taxpayers will end up having to pay that difference.
Yes.
And yeah, but
Oh.
right, 2025 is when it comes up for reauthorization. That's what I thought.
Oh, 2025. Oh, yes, because it was
Right.
renewed in 2005. Okay. So Linda Ryder, would you mind unmuting? And yeah, there you go.
Hello, thank you. I'm very novice about this stuff, but I was wondering if there is any micro reactor operable in the world. And my husband looked on the internet and said there's something in Russia. This is just all, nothing's been tried. Is that true?
Yeah, I mean, in Russia, it's after many years, they finally deployed what they call a barge-mounted reactor, which is it's bigger than a micro reactor. I think it's 40 megawatts to 40 megawatt units. Micro reactors are typically under 20. And no, there hasn't been in modern times any power reactor that's that small. But the
Okay.
Department of Energy is building a prototype called Marvel in Idaho, and they claim that it'll be up and running next year, I think. So we'll have to see. But so far, no.
Okay, thank you.
Okay. Francis Lawrence, would you please either, I will read your question if you don't want to, but you could go to the chat and read the question that you put in there, or.
Oh, yeah, okay. My question is, if the industry had its way completely, how many sites would you envisage that they would build? How much space do these sites take up? And my other question is, other than the energy committees, what other congressional committees are involved with this, have some degree of oversight, and who specifically would our allies be?
Right. So the first question is how many? I certainly say that some in the industry have grand plans. So I've heard, but I mean, it's all talk. And I think the fundamentals aren't there, because the economics of a micro reactor are just going to be terrible no matter how much you can roll back safety and security. But I hear Oklo, their business model, they think would only make sense if they can make hundreds or thousands of these. So that's what they're talking about. I heard, a professor at Penn State University just 2 weeks ago, they want to turn Penn State into a technology hub for microreactors. It would deploy them all over Appalachia to every town that, had a defunct coal plant or a coal mine. They're going to give them a microreactor, and it's going to save their economy. It's fantasy, but it still has legs. So I can't really predict, if there's enough government subsidy, which is what we're really talking about here. I expect there might be several actual projects, mostly on military bases at first, but I just don't see how the technology can overcome the problems of the fundamentals.
The financials.
Well, and I mean the technical fundamentals, which include the financials. Now, as far as Congress, the industry has been lobbying heavily on both sides of the aisle for many years, and it really has borne fruit. The committees with jurisdiction over over NRC, that's the Environment and Public Works Committee in the Senate, primarily. So they do have oversight, but that committee, even with Democrats at the fore, are still very pro-nuclear, and they only raise nuclear safety issues as sort of an afterthought, or if they want to score points against the Republicans, for example. The Energy Committee, has oversight or authority over DOE, that is Energy and Natural Resources in the Senate, or so they could, well, that's authorization authority. Then you're also talking about appropriations. It's Energy and Water, the subcommittee, the Appropriations Committee, that's the one that holds the purse strings. They could help shape how the department's spending money, because DOE, it's really subsidy that's driving the only reason why these projects are happening at all, like TerraPower, is because of this large amount of public money that DOE is funneling into them. So it really is the Energy and Water subcommittee, appropriation subcommittees, that have the real power to shape how DOE spends its money, and they could end a lot of this in one fell swoop. But unfortunately, these committees are also taken with the idea that we need nuclear power to combat climate change, that advanced reactors are going to be better, cheaper, and also there's this idea, it started in the Trump administration, but it's carried over, that nuclear power is the best, is a great way for the US to increase its sway in the world by exporting nuclear reactors, by turning us into, a nuclear power exporting country again, to compete with Russia and China. And that has an awful lot of sway also now at Capitol Hill. So you have the hawks and the climate change hawks, and kind of in an alliance, and that's led to this very strong pro-nuclear faction in Congress, and that's why a lot of the reason why we're seeing all this activity right now.
Okay, thank you, Francis Lawrence. And I wanted to remind everyone it's now 3 minutes past the hour. And I believe Ed said he wanted to end at the half hour. So we really have less than half an hour to go. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 people on the list. So please make your question as quick as possible, and we'll try to get through everyone. So our next questioner is Ann Berger. Please unmute yourself, Ann, and ask your question.
Dr. Lyman, like Clark Bullard and Bruce Hannon, I'm calling from Urbana, Illinois. As you may know, the university has submitted an application for license for a micronuclear reactor that as a research reactor, but it will also, I guess, supplement our local the campus gas and coal-powered plant. They have said a local person has asked a nuclear engineer who is one of the investigators of this proposed reactor, and about this. I'm going to quote him now. This nuclear engineer said that this microreactor is not falling under Part 53 of the NRC guidance. What I'd like to know is, what does that mean? Does that mean they will allow themselves to be subject to regulations for the large power plants? Should we be reassured by that?
No, I think it means they're going to submit an application as a research and test reactor. So
They are.
I assume. So if that's the case, that's under a different, it's Part 50, but a different provision than power reactors. And the problem with that is that, and actually, I don't know. I haven't been following it closely enough. So if it is, they are allowed to call something a research and test reactor if producing power is not its primary function. And I think actually in NEMA, they changed the percentage of the amount of time that the reactor would have to be producing power, the percentage of its capacity. So I'll have to get back to you on that. I'm not actually sure, but if they do license it as a research and test reactor, then it falls under much weaker standards and even the current power reactor licensing. And that's one of the reasons why university reactors, research and test reactors, don't have containments. Most of them, they are regulated to a lower standard, even if, as I believe, even a smaller reactor could have significant radiological impacts if there were a severe accident or a terrorist attack on the vicinity, that they're still licensed to a weaker standard. One concern I have is that the NRC is the industry is making the case that these micro reactors are going to be as small as current research and test reactors that are at universities. So why should we regulate them any more stringently? But the counter argument to that is that the Atomic Energy Act originally designated research and test reactors as a category that shouldn't be regulated that stringently because they were supposed to be for education. So it's not logical, but that's sort of where the NRC is going, and it's thinking about how to license micro reactors, is that why don't we just license them like we do research and test reactors? And that's another kind of dangerous development. But I don't know the details about what University of Illinois is planning right now, so I'll have to check.
Thank you.
This issue is probably not going to come up until the first of the year, and it's against the law in Illinois to build a nuclear reactor because until the federal government has a deep geologic repository for waste, and the Nuclear Energy Information Service is taking a very strong stand against this reactor. And Anne, please put your email in the chat so that we can contact you. Okay, and now let's go to Cale Walker. Unmute. Oh, good.
Hi there. Thanks so much, Ed. That was a really concise synopsis of a horrible list of problems. The one thing that wasn't talked about too much is the fuel, the advanced fuel, but the waste. And the NRC is not looking at that. I listened in on a NRC meeting on, what was it? It was source term stuff for the sodium fast reactors. And so I sent an email to the guy who ran the meeting, and I said, and they named 5 reactors, test reactors, or reactors that had happened before. And I said, can you tell me what the disposition of the waste is? And he didn't know. He said, let me ask my colleagues. Nobody in the NRC knew. So he sent me to INL to see where the sodium waste is. And there is no solution for the sodium waste. There's no containers that are good. You can't, I mean, they'd have to do huge reprocessing. So I think that, and for any of the waste, that the high assay, low, they all have to be high burn up, which is going to create a huge debacle with another level of problems with the waste. I personally think that's a really strong pushback on this whole thing, is to say, hey, DOE, you're dumping billions and billions and billions and billions of dollars into these new fuels, new reactors, and you're not even dealing with the current waste problem. And you're completely ignoring the waste aspect of this. So that's my comment. Do you have any, my question would be, do you have any insight on how they're avoiding addressing part 72 and part 71 through this part 53 process?
Well, I think their intention is not to modify the, the part 53, is focusing on the operating reactors. So it does address, the on-site spent fuel storage to some extent. But I don't think they see that. I think they're going to be handling those considerations under different regulatory avenues. So
I think every reactor site will become a waste dump as well, these small modulars. So communities might want to know that. Thanks so much.
Okay, our next questioner is Arnie. So Arnie, go ahead.
Okay, I'm sorry. Hey, Ed, thank you for a terribly depressing discussion. I wanted to mention there's a reason why Bill Gates is building his power plant in Wyoming. And that's that the ranking member of the Energy Committee, I think his name is Basaro, is from Wyoming. There's also talk of building small modulars in West Virginia, because the head of the Energy Committee is Manchin. So this is a very political siting process. I put the bones of this issue up in the messages at 8:55, so I'll be real fast. These plants are replacing coal plants, and the asset is the transmission line. They're trying to keep that transmission line from being used by renewables. I notice a lot of people on this call are from the west of the Mississippi, and that's where most of these are under consideration. And farmers are your friends in these battles, because windmills, wind turbines on farmers' land generate income for many more people than the income of a small modular that replaces a coal plant. So from the political side, the activists on this call might want to consider working with farmers as allies in preventing these nukes from being built. I had no questions, Ed. It's you're phenomenal. You always are.
Our next questioner is Sarah Fields. She's put several things in the chat. And I wonder, Sarah, if you could kind of consolidate your comments and questions and let us know what's on your mind.
I just gave some people some additional information. So most importantly, I think that people should look to the state and local laws and regulations and local land use codes. And if enough people with some legal experience can look into that, I think that there could be a map and information, a map meaning a guidance and information for people in different states and localities to get on top of this before the nuclear industry gets on top of it.
Well, thank you, Sarah.
That's it.
Okay.
So it may be a subject for additional, definitely a subject for additional discussion.
Yes. Alfred, please unmute yourself and go ahead.
Yes, I'd first like to thank NEIS and you, Jan, in particular, for organizing these events. And I'd like to thank Ed Lyman for his decades of wonderful service with UCS, Union of Concerned Scientists. I have two quick questions. One is, if you're familiar with this book, The Cult of the Atom, by the executive director of UCS in 1982, Daniel Ford, because when you talk about what the NRC is up to now, it sounds like it's just a repeat of the history of the Atomic Energy Commission. So I just have one question, is whether you have any comment on that historical continuity that we're seeing in our regulators, I would argue. But my second, more pertinent question perhaps is, I'd like just to say I'd be interested in working with anybody else who's interested in getting a kind of working group together to network public response to these rule makings, and a few talking points, just a basic strategy, and in particular whether you can identify where the pressure points are legislatively in the decision-making process of these rules for NRC. Thank you.
Okay. Thank you, Alfred. And Alfred usually likes to talk about the connection between nuclear power and weapons. And that's, of course, related, but it is another subject. And we're very happy to have you here. Michelle, oh, wait. Yeah, Michelle is next. And then we've got people from the chat. Stephen Sondheim, Pat Marita, and Mike Keegan. So
Jan, I'm sorry, wasn't there something Alfred was asking Ed to comment on?
Oh, sorry, go ahead.
Yeah, right. So first, I read Cult of the Atom in college, and it was very inspirational at the time. Yeah, well, the depressing thing is that a lot of the lessons that the agencies, well, certainly back in the 70s, a lot of the lessons that the agency learned then, soon after it was created, seem to be forgotten now, and I think that's the problem. I don't want to, quote the usual cliche, but they do seem to be ignoring the lessons of the past. So that's a problem. The next pressure points is, as I said, just weigh in, write letters, attend public meetings, and talk and complain in the public comment period. Just push back, because the industry is pushing against this open door. But the next formal round won't be until they publish the draft rule, which is not going to be until, like I said, August of 23 at this point. So keep an eye out for that.
I'd like to talk about how to get into these public meetings. Michelle, let's have you ask your question, and then we sort of need to tell people how to get into the public meetings.
Yeah, so the most horrific aspect of this whole deal seems to be the security implications of multiple coordinated attack on many different reactors at the same time. And this scheme goes forward, you're dealing with a threatscape going well into the next century probably. But putting that aside, what strikes me as a consistent Achilles heel across a lot of the sketchy reactor design concepts that I've seen is vulnerability to extreme climate, extreme weather events, landslides, wildfires, massive floodings, because even if you have passive cooling, you can have that cooling blocked, you can have structures collapse, you have infrastructure unable to accommodate mitigation of an event. And very likely you have loss of offsite power across a very widespread geographic area. So I'm just wondering if you agree with me.
No, I think I think you're right. And, it's another talk really to go into the details of what the defects of these different designs are and why it doesn't make sense to relax rules. But yeah, no, certainly external events are typically the biggest problem because they claim, if you design a passively safe reactor that's really against internal accidents, right, a pipe break or something. But if you have some external event that's strong enough, it will defeat those passive safety measures. So, one example is NuScale, where it seems like the seismic analysis was really getting in the way of their ability to show that they don't need an offsite emergency planning zone. So they tried to get around this by saying we're going to screen out the most severe earthquakes using a different standard than the way we screen out other low probability events. And the NRC didn't buy that. So then they came around and said, okay, we're coming up with a proprietary method for how we're going to analyze seismic events. And that's what's currently, and then the NRC approved their topical report. So now it's a secret, but if they really could treat seismic events, in a consistent way, they wouldn't have to keep it a secret, right? So obviously there's an issue there.
Okay, we have people from the stack, Stephen Sondheim, Pat Marita, and Mike Keegan. Then we'll call on our board member, Gail, but let's start out with Stephen.
Okay, hi, thank you very much, Ed. I'm Stephen Sondheim. I live in Chicago. I'm part of the nuclear team of the Sierra Club. My question's about the economics with your best estimate. It seems like there's sort of a race between significant impact on climate change and these nuclear things being implemented. In your best estimate, even if they're allowed to do everything they want to do with very few safety things and whatever, how soon could they make a significant impact? And my guesstimate is probably not till 2040. So in a way, it seems moot. But anyway, I wondered what you thought about that.
Yeah, I think that's probably right. Because, and again, it depends on the design you're talking about, but, most of the non-light water reactor designs that are currently being funded and require this, high assay low enriched uranium, which the U.S. currently doesn't produce. And even trying to stand up the fuel cycle for producing and fabricating fuel made from that material, transporting it, all of those things take much longer than some people might expect. I mean, just designing and certifying a transport cast for a different type of fuel can take years, and then you have to build them. So none of this can be done quickly. The one exception might be light water reactors like NuScale, where again, the supply chain is not that different. They're not using a radically different fuel. But even then, the NuScale, the idea was conceived around 2000. The company was founded a few years later. They're still not anticipating have the first unit operating until 2029. And of course, the idea is once we have the first one, then the others are going to be, multiplying like rabbits. But again, that unless there's a firm contract in advance that would enable them to build a factory to produce enough modules, that no one's going to make that investment. And so even with all the support the Department of Energy is giving, it still seems to be dragging along. So I don't think realistically there's going to be a massive expansion or deployment of these reactors. Certainly not in time. Certainly not by the early 2030s. So I agree with you.
Follow-up question is sort of, I guess, the question was going to be, what the heck are the rates to the consumer going to be? My guesstimate is they're going to be huge compared to what we have today, or even renewables. But the other part of that question that I just thought of based on what you said is, who's going to pay for all this building? And you seem to imply there's a lot of money from the government, but did you seem to say that there has to be extra money? I'm asking two questions, I'm not sure, but is there going to be enough money to build these things? But the other part of the main question I want to ask is, are these rates going to be out of sight? Thank you.
Well, those are related, because part of the money that the government would have to expend would be, somehow subsidizing ratepayers, because if these are going to be commercial units, they're going to be constrained in the rates they can, charge, and so they're going to have to make up, if they're not going to lose money, they're going to have to get reimbursed, from somewhere else. So I think the Department of Energy is dreaming of these other arrangements, kind of long-term power purchase contracts that the department would buy at above market rates, and then, end up with taxpayers subsidizing the difference. That's probably the only way it can happen, unless the cost of these reactors comes down radically. And I think the expectation is, the government just have to give the industry a boost, and then it'll just be able to thrive on its own. But, that's an experiment that could really take decades to prove out. So the bottom line is, either, what the ratepayer doesn't pay, the taxpayer would pay, or it's not going to happen. Venture capital is not, going to finance a fleet, enough to build fleets of these reactors. I don't think it's going to happen.
Thank you. Thank you.
You can go down to the bottom of your screen where the video icon is and take a look at yourself, and you'll know who's going to be paying for these. Our next questioner is Pat Morita from Ohio. She's the spark plug of just the resistance to unbelievable stuff that's going on in Ohio. So let's hear from Pat.
Yeah, well, my question was already kind of answered, because I was thinking about getting, congressional hearings, public hearings about this. And certainly it behooves all of us to join Alfred and work to try to raise the awareness level of the public and the media and our elected representatives, because they've swallowed the Kool-Aid about ultra safe and no carbon. It's amazing how uninformed everyone is.
Do you want to comment, Edwin?
No, I think I understand the comment. No, it's right. There are very few champions on Capitol Hill right now to offset this push, and that is a problem. But there's always room for education, and I wouldn't stop trying.
I think we're going to go over just a little bit, Edwin. Mike Keegan is our next commenter, and he's the other way to get into the public meetings. Get on his mailing list, because he sends out much information about meetings of the NRC or the DOE or any industry that's having a meeting. And so you'll get more information about meetings than you could possibly handle. And Mike, send your email to Mike. So Mike, talk.
Thanks, Jan. Thanks, Ed, for the presentation. I'm battling against the HALEU that's enriched up to 20%. All this, the new generation, the advanced reactors, the SMRs, they all seem to be a fig leaf to cover the real agenda is to get at the enriched uranium. I'm concerned about the proliferation aspects of selling these reactors around the world that are using 20%, 10% enriched fuel. Could you speak to that?
Yeah, I should say that I'm just finishing up membership on a National Academy of Sciences committee that was looking at advanced reactor fuel cycles, and I actually wrote a large part of the chapter on proliferation terrorism. So that's going to be coming out, should have be coming out this month, is my understanding. It might be delayed, but I would look out for that, because even though it's a consensus report and I had to fight, I'm not supposed to talk about what happened behind closed doors in the committee, but it was a struggle to keep some stuff in. But I think you're going to find some useful things in that report. It is a concern. It's a concern of mine. I think Department of Energy is downplaying it or ignoring it. And I intend to do a lot more work on it once I get off this committee and I can talk more freely about it.
Okay, Gail, you're up.
I have two questions. One is, it's become abundantly clear to me here in Illinois, where we have a moratorium on building new nuclear reactors, and there are some efforts to try and lift that moratorium, that the reasoning is to try and get on the ground floor of a new industry, which is some sort of small modular reactors, micro reactors, so that we can compete with other countries. And this was pretty clear in a House testimony hearing that I attended. So my first question is, what is happening in other countries with these small modular reactors, micro reactors? What are they doing? What is the status in other countries, and what are their safety standards? Are they also kind of throwing them out the window? So that's question number one. And the second thing is that, currently our existing large nuclear reactors are regulated by the NRC, and states don't really have any authority. I'll say they don't have any authority to really do much to regulate those reactors or impose anything upon them. But I would think that if they're going to lower the safety standards drastically for small modular reactors, that states' abilities to try and do something to ensure safety should be raised up, especially when you can get states that are going to be competing with each other for these reactors and doing what other countries do. Put them on the border of your state boundary so that if it blows up, it blows downwind into your neighboring state. Or likewise, municipalities will be in competition with each other to, here I'm over by Argonne Laboratories, maybe Argonne Lab would like to get that, and that would be, in competition with a neighboring municipality that's adjacent to that, and maybe they would want one over there, or maybe each municipality want to have their own power supply, like some of them do here, either, running on a various, natural gas and things like that. So do you see that there's any mechanism to try and get states a little more involved in the safety aspect of this? Because as the NRC kind of backs down on safety, shouldn't the state be stepping up on safety?
All right, so to answer your first question, I mean, if you listen to the International Atomic Energy Agency, there are hundreds of small modular reactors being developed all over the world, la-di-da. But if you look at the reality, again, like it is here, it's mostly talk. Like China has, developed one or two designs. I don't think, I haven't heard that they've actually managed to sell one. Argentina is supposed to be working on one that's been delayed. Russia, has these large reactors, but it's, it's really still like it is here, mostly talk. And given that, I think the fundamentals aren't there, they aren't affordable, they aren't economic, so they would require, any country would have to invest a lot of money in them. But I think what the US is afraid of is that these other countries give low or no interest loans. Essentially they're giving these things away and that and if the U.S. doesn't do the same thing, then they're going to lose out on this great export market. So, but mostly it's still the specter of, you know, we're going to lose out in our authority, in our influence abroad if we're not exporting nuclear reactors everywhere. You know, same as the 1950s mindset, you know, during Cold War. But I think, again, the fundamentals are the same, unless there's a lot of subsidy from somewhere. No, very little of this is going to happen. But there, you know, but the U.S. is out there trying to peddle, you know, these reactors in Africa now, you know, in Ghana, in Eastern Europe. So it's a little troubling what the lengths the U.S. is going to try to support this domestic market, export market. About states, you know, you did remind me I had this idea before, you know, so if you think of the Texas law that, so I don't veer into, you know, other areas, but the Texas law that got around the fact that abortion was, you know, protected on a national level by allowing individuals to sue, you know, these individual lawsuits. That was getting around that, you know, that national legalization. It did occur to me that a state could pass a law like that that would enable an individual to sue a company that was, you know, or a utility that wanted to build a small modular or a nuclear reactor. That would essentially bypass the NRC's preemption authority. So, so that, you know, that for instance, like Texas could have used that, I think, to try to prevent the interim steward. They went a different legal route, as we know, but it seems to me that would, if you're thinking of ways where a state could subvert national authority, that would be one way to do it. Now, what would be the grounds for suing, you know, a company that wanted to build a nuclear reactor? You'd have to be creative, but if the state authorized that, then you could make, you know, it could make it prohibitive for a company to try to do it.
Yeah, just a follow-up comment on that. In our state, we've had 3 recent industrial incidents here. We had a lithium fire. Somebody illegally stockpiled lithium batteries in a factory, and that caught fire, and an area had to be put under you know, lockdown while the fire was burning. We had a big chemical plant fire, and then we had this thing that a lot of people probably don't know about, but it was Sterigenics, which is a company that had used ethylene oxide, which is carcinogenic. You can't see it, smell, or taste it. They released it into the environment in the upscale suburban community. And for the last 30 years, people's cancer rates have gone up over there, and nobody really knew why until they realized this nondescript building was emitting a chemical into the community. So we've had these 3, what I would call most recent significant incidents here in Illinois, and every state has some sort of significant incident. And I would think, based on those safety hazards that we've seen happen, and the state should be able to regulate those things better, I would think that it would be a natural progression that a nuclear incident should also be regulated.
Yeah, but you know, the obstacle is the Atomic Energy Act and this preemption authority, which, you know, gives, you know, the NRC supreme authority to regulate anything having to do with the safety of a nuclear reactor. And that, you know, unless you change the law, you can't get around that, unless, you know, the Supreme Court were to carve out more exceptions. For instance, in the Virginia uranium case, where the Supreme Court allowed this Virginia's ban on uranium mining to stand, that raised certain kind of carved out some exceptions to the NRC's preemption authority, so that there's space there. But unless the Atomic Energy Act was changed, or there's very little you can do for a state to regulate safety. But that's why I was thinking, if the state passed a law that said a private citizen could sue a utility if it wanted to build a nuclear power plant because, let's say, it was afraid it would impact its property values. That you're not talking about safety, and you'd have to see how that would stand up if we're challenged in the Supreme Court. But it's one avenue.
Great. Thank you.
Well, you've been a really good sport, Ed. And, I've got a few little comments I would love to make, but I know that it's 20 minutes now to the hour. And there were two, I guess, I'll try to keep it to, three, because Dave Lockbaum put into the chat another way for you to find out about NRC meetings. So please, we can send you the chat if you want it, or you can look right now. It's just two from the bottom about how you can figure out how to get to these NRC meetings. And Ace Hoffman has put in place of his own picture, a picture of Cult of the Atom, a book. And I believe that's the book we've been discussing. So you know what it looks like if you decide to buy it. And I wanted to introduce our board member who's come on, Linda. We would like you to acknowledge you as a member of the Board of Nuclear Energy Information Service, and just say one or two things about yourself.
Hi, I'm glad to be here, and I'm really, really happy, Ed, about all that you've introduced, the information you've introduced to learn and really update our level of knowledge of these intricate subjects. Thank you.
And I've often wondered what parents think about sending their kids to a campus where there's a nuclear reactor. I wouldn't want to send my child to a campus that had a nuclear reactor on it. And I think that we can now close this meeting, and that would be turning the situation over to Gail or to Dave if he really feels like saying anything. So let's, Gail, you take over right now, okay?
All right. So I just want to thank everybody for coming on. This was recorded, and we will put this up on our YouTube site at some point. We're trying to finalize getting our backlog done and getting them up there. But once we get them out on our YouTube site, you'll be able to share them with other people, which would be wonderful, especially with your legislators. And I want to thank Ed. Ed, if you could just stay on while everyone else signs off so the board can just talk to you for a couple minutes at the end before we sign off. But thank you, everybody, for coming on.
I do want to sincerely thank you, Ed, for coming on tonight. And this has been an incredibly informative thing, very important to the people who attended, very personally. In the past, we've also had Dave Lockbaum, formerly with UCS. If we ever find Bob Pollard, I suggest we have a three-way reunion with you guys. These are three of the most incredible UCS scientists who have helped this movement for decades. So thank you very much, Ed, for being with us tonight.
Thanks.
I want the folks to know that there are two, they're not exactly coalitions, they're informational sessions that are taking place on small modulars. We've convened one for the Great Lakes and Midwest, which meets on the first Wednesday of each month, 12 noon Central Time. If you're interested in participating in that one, put your email in the chat box. And I'm told that after the first of the year, NEARS is going to be launching a Stop New Reactors project. So there will be another opportunity to get involved and take on these new reactors. As you can see on the share screen, NEIS has been offered the possibility of getting $5,000 through a matching grant. And I want to stress this because if we get the $10,000 combined, it's dedicated money, and 75% of that has to go to fighting the small modular reactors here in Illinois and in the Midwest. So if this is an issue that is warming your heart, these are two ways that you can help fund that. and help our work at NAIS make that happen. And then finally, I just want to wish you all a very happy Thanksgiving next week and hope everyone is safe and has a good holiday. So that's about all my voice will allow me to say. So thank you again, Ed. So have a good night.
You too.
Thank you everyone else for coming on tonight, and we hope you can make it to our next night with the experts.